In this section, we're going to be determining if a certain relation is a function. So we're going to describe the relationship between a relation and a function. So let's talk about what a function is. We're imagining a function as a sort of a machine, and we're plugging things in called inputs, and we're calling them x. So we're plugging in x. The machine is going to do some work with x, and it's going to spit out an output, and we're calling this output y, or we can call it f of x. Okay, so for each input x that we put out, our machine is going to put out a specific y, a specific value for f of x. Now, if we put in a number x and it spits out two different answers, if it puts out two different outputs, our machine is therefore broken. It's no longer a function. If we plug in x, f of x can only give us one value. This is called being 1 to 1. The relationship is 1 to 1 if we plug in an x and we get f of x. If we plug in x and we get two different f of x's, we no longer have the relationship 1 to 1, and therefore what we're looking at, the relation, is not a function. So our machine therefore breaks down and we no longer have a function. So what we're going to do is we're going to look at a few examples of these. We're going to be given a set of points, and we want to know if the relation of these points represents a function. So here we go. Let's say we have the following points. Somewhere out in the world, we have a relation of points 0, 1, 1, 3, -1, 4. Let's say we have the point 1, 5, and the point -2, 2. So we have a relationship or relation somewhere, and we want to know if these points, the relation of these points, represents a function. All right. So first off, we want to know that if each value of x has a unique value for y. In other words, for each value of x, are we given a unique value of y for everywhere we see the value of x? Well, I can tell you right here and right here we have a problem. We have the value of x equals 1, and we're given two different values of y. We're given 3 and we're given 5. So when x is 1, when we have an input of x into our machine, we're getting two different outputs. We're getting 3 and we're getting 5. So this right here tells us that we do not have a function. We have a relation, but the relation is not 1 to 1. It's not 1 to 1, so we definitely don't have a function. We have two different y values, or two different f of x values for the same value, the x value 1. All right, so this is not a function. Let's look at another one. Let's say we have the relation of the following points. We have -3, 4. We have -2, 1. We have the origin is included in here, 0, 0. We have -1, 2. And we have -3, 4. We want to know if the relation of these points consists or represents a function. So what we want to do is we want to find any points that actually have the same x value. We have it right here. We have -3 appears twice, and as long as the y value or the f of x value is the same in both cases, we do have a function. And here it's 4 in both cases. So every time we plug in x into our machine, we plug in -3 into our machine, it spits out one unique value. And here that's the case. We have 4. So it doesn't matter how many -3s we plug in, we're always going to get 4. So that's what it means when we say it's 1 to 1. So this is indeed a function. A function. Okay. Let's look at another example. Let's say we have the relation that consists of the points -2, 4, -1, -2, 0, 4, 1, -1, excuse me, it's a little bit messy, 1, -1, and 2 minus 2. Okay, so when we're given a set of points, we're given a relation that's described by a set of points, the first thing we want to identify is if we have any x values appearing twice. We have minus 2, minus 1, 0, 1, and 2. All of our x values are different, so we can actually say that this is indeed a function. There's no points that share the same x value and spit out different values. This actually just doesn't share any x values at all. Now notice we can go in the opposite direction. We have two values here, minus 1 and 2, that spit out the same output of minus 2. That's okay. We can plug in minus 1 for our input, and our machine can give us a minus 2, and then we can plug in 2 as our input, and the machine will spit out a minus 2 as well. That's okay. We can go in that direction, but as long as we have a unique output for each x value, which is indeed the case here, then we have a function. Let's go ahead and look at one more. Let's say we have the relation 3 minus 3, 3 minus 3, 2 minus 2, 1 minus 1, the point 2, 2, and let's just go ahead and include the origin in here as well. Okay, so what we want to know is we want to look and see if we have an x value included in the relation of points that appears more than once. And here we have the x value 2 appearing in 2 different points. So then we want to look at, well, are the f of x values the same? Are the y values the same? Here we have minus 2, here we have positive 2. This is a no-no, so this relation is not a function. It's not a function because we're taking an input, x equals 2, and we're plugging it into our machine, and we're getting 2 different outputs. We're getting a minus 2 and a 2. We can't have this, and this is indeed not a function. Okay, we'll look at a couple of more relations, or relations described in a couple different ways other than just a set of points, and we'll find out if those relations are functions, and we'll do those in the next couple videos. I'll see you soon.